Hello and welcome to the introduction on how to use the slide navigation and interactive features in Storyline 360. At the top of the slide, you can see the module number, and lesson name, indicating the current lesson. The player bar is located at the bottom of the screen. It includes the play-pause button on the left, the seek bar that allows you to control the slide timeline by dragging it, and the replay button to restart the slide. You can adjust the volume by clicking on the speaker icon. To enable closed captions, simply press the CC button. You can also adjust the playback speed by clicking this button here. Additionally, there is a full-size screen option available by clicking the screen icon on the right-hand side. If you want to skip slides, there are two options available. The first option is to use the next or previous buttons located at the bottom right corner of the slide. You can navigate through the slides one by one using these buttons. The second option is to open the menu bar by clicking the highlighted icon at the top left corner. In the menu, you will find a list of slide sections. Note that the current slide will be highlighted whilst the slides you have already viewed are marked with ticks. By opening the menu bar, you can jump to any slide you wish to visit in this lesson. However, it is possible that some lessons may have this feature restricted until you have viewed the slides in the prescribed order. If you click on the Transcript tab on the right side of the menu, you will have access to the transcript. To search for specific slides in the lesson, click on the magnifying glass icon and enter the keyword to initiate the search. If there are resources available for the lesson, you can easily access them by clicking the Resources button at the top right corner. When a hand cursor appears on a slide, you can click it to jump to the corresponding timestamps. This feature allows you to quickly navigate to the mentioned points or highlighted sections on the timeline. If you would like to learn more about EIT's world-leading education and training courses, click on the screen or visit us at our website. We look forward to supporting your professional development journey. From all of us at the Eggler Institute of Technology, we wish you all the best for your studies. Hello, my name is Mark Eggler and I would like to welcome you to this historical overview. During this module, we are going to spend about 1 hour learning about the historical background covering the development of military vehicles. I'm sure you will find this module most interesting as it provides a great contextual background to what you're going to learn during the remainder of the course. The history of military vehicle development is a fascinating story. As you will learn, all developments in fighting vehicle technology were dependent on the discovery of preceding technologies, such as gunpowder and specialist steels. I suppose that shouldn't surprise anyone. But in relation to fighting vehicles, you'd be interested to learn that there was a surprisingly slow take-up by armies in the West, and a strong resistance to the implementation of key technologies in battlefield-winning vehicle designs. It was a very slow and painful process, as armies came to grips with trying to understand the new technology, and develop appropriate tactics, techniques and procedures. This is particularly true of military vehicles designed in the West. Given the very strong cultural military traditions of the early 1900s, it took a lot of experimentation to fully understand the integrated benefits of mobility, firepower, and protection, and incorporate these into new vehicle designs. If we look back to the very early days of fighting vehicle design, we need to go back to about 3000 BC. The very first recorded fighting vehicle designs are known as the chariots of Ur. This vehicle carried 2 armed men, and as you can see in the diagram, the vehicle was designed to carry a range of loads, such as spears and other types of stores for use on the battlefield. The chariot was towed by a horse to give it a degree of speed and mobility, and the sides were marginally protected. But you will note the vehicle didn't have any suspension, so it must have been very uncomfortable to ride within this vehicle at any speed. The next breakthrough in fighting vehicle design came about in 1482. You can see here the first early fighting vehicle designed by Leonardo da Vinci. It was quite ingenious for its time and incorporated the first known turret observation tower used in a military vehicle. It provided limited protection, using a thin metal plate, and was operated by 8 men. As you can see, you clearly didn't have much mobility and rather limited observation as well. Firepower was provided by a number of cannons placed at the base of the vehicle. The vehicle was never deployed in battle, but it was an important first step. Before military vehicle design could proceed in earnest, there was a need for the discovery of a broad range of precursor technologies. These included the discovery of gunpowder by the Chinese around 1350, and the development of cannons and artillery around 1400. There was obviously the need to develop engine technology in order to provide a means for the vehicles to move. The first 4-stroke engine design was patented by Rorschach in the early 1860s. Fighting vehicles also needed protection against ballistic threats, and thus benefited from the first large-scale production of steels, which occurred in 1856. Then in 1900, Rudolf Diesel demonstrated the effective use of the first diesel engine. As we know, diesel engines have become the backbone of all heavy fighting and logistic vehicle designs. Importantly, in 1904, there was the development of the first commercial agricultural tractors. This was essential to the design of fighting vehicles because of the track shoe technology, which allowed superior mobility in difficult terrain conditions. In the early 1900s, the application of steam engines to commercial agricultural tractor applications was born. This was an essential first part of fighting vehicle development. As you can see, in 1904, Holt built the first commercial half-track tractor. Then a year later, Mr. Hornsby built the first full-track commercial tractor. So, you can see that the development of the tractor was an important first step in the design of fighting vehicles. Early fighting vehicle development started apace in the early 1900s. This obviously relied on the development of precursor commercial technologies developed to support civilian and agricultural vehicle design. Early thinkers in the military domain could see the utility in taking a range of these commercial technologies and applying them to the design of fighting vehicles. Some military thinkers, but not all, could see such designs would provide much-needed improvements to mobility, and provide a platform to mount weapons. The real impetus for fighting vehicles came from the trench warfare of World War I. They needed to have some form of capability that could breach trenches and provide protection to the advancing infantry. Believe it or not, the idea for the first armoured fighting vehicle was developed by the British Royal Naval Air Service. At that time, they had the requirement for an armoured car. But it wasn't until Winston Churchill finally took the initiative and established the Land Ships Committee, that we finally see the emergence of the first tank design. I find it quite ironic that the tank emerged from a naval committee. In the next few slides, I will introduce you to the first key early military vehicles. These included the Delaunay Belleville armoured car, the British Mark I tank, otherwise known as Big Willie, and the French Renault FT light tank. In 1915, we saw the design and development of the first tracked armoured vehicle by the Royal Naval Air Service. This vehicle integrated the British Delaunay Belleville armoured car body onto the American Killen straight tractor. As you can see, it's a rather large and awkward-looking vehicle. Of note, we can see the integration of track technology to provide mobility on difficult terrain, and the use of a heavy armor plate to provide protection to the crew. It was a novel design for its time, but the project was abandoned as it turned out to be a blind alley, with the vehicle unable to meet all-terrain warfare requirements. In 1916, came the first big breakthrough in fighting vehicle design. As mentioned earlier, this involved the design of Little Willie, and followed shortly thereafter by Big Willie. The vehicle was designed under extreme secrecy and deployed to the Western battlefront, and fought for the first time in September 1916 at the Battle of the Somme. The key operational requirement for the vehicle was to be able to cross 1.5-meter trenches and 1.4-meter high parapets. It was this requirement that led to the unusual rhomboid shape of the vehicle. The vehicle itself was heavy, weighing 28 tons. There was no suspension, and the vehicle was fitted with 2x57mm or 6-pounder guns. The vehicle required a crew of 8 to operate it, with 4 involved in the driving process. The maximum vehicle speed was 5.9 km per hour, and its range was limited to only 37 kilometers. In its first operational deployment, the newly designed tanks did not acquit themselves well on their first day of battle. They were very unreliable, with many of them breaking down within the first hour of operation. Given this was the first time tanks were used operationally, senior commanders didn't know how to correctly employ them in their battlefield plans. At that time, they were viewed as a support vehicle to infantry operations, rather than being fully capable of fighting on their own and supported by infantry. The new tank would have to wait until 1918 to fully prove itself at the Battle of Cambrai. Another important World War I design was the French Renault FT light tank. This vehicle was designed and deployed in 1917 in very large numbers by the French army. It consisted of a crew of 2, mounted a 37mm gun, and was rather light at 7 tons. It had a number of novel aspects to its design, including that it was the first tank to use a rotating turret, and what would later become the established configuration for tank design. In this vehicle the driver sat at the very front between the 2 tracks. The turret was mounted mid-body, and the engine located at the rear. Between World War I and World War II, fighting vehicles underwent significant technological development. The key breakthroughs of that time included the development of the U.S. Christie suspension, known for its design to provide high mobility, significant developments in engine technology improving vehicle power-to-weight ratios, and the mounting of larger caliber guns. These developments were a precursor to the continual battle between the key characteristics of fighting vehicle design that cover mobility, firepower and protection. It was also a period of great experimentation. There was experimentation around the design of amphibious vehicles, the development and testing of vehicles using laterally flexible tracks, as found in the Tetrarch light tank, and a fascination by armies to mount multiple machine guns on vehicles. The latter arose from the thinking of that time that fighting vehicles were primarily a platform to support the infantry. In the 1930s, the British led the way in the design of new fighting vehicles, and conducted a large number of experiments on the Salisbury Plains. This experimentation, which was highly innovative for its time, was to develop what we know today as maneuver warfare. Interestingly, the British invited the Germans at that time to observe these early experiments being conducted into the use of fighting vehicles. At this time, the British failed to see the operational value of combined arms operation between armoured units and infantry, and didn't develop appropriate tactics, techniques and procedures to fully exploit the military potential of fighting vehicles. However, the Germans fully appreciated the potential for maneuver warfare and adopted this doctrine into their military plans. They used this to devastating effect in the early stages of World War II. One of the earliest and most effective tanks was the Russian BT-7 tank. It adopted the Christie suspension, which provided it with the ability to travel at very high speeds. Its top speed was 68 km per hour. It also incorporated a novel design that allowed the vehicle to either run on wheels or tracks. Another important design in the interwar period was the British cruiser Mark II tank. The importance of this design is that it introduced what was to become the standard tank configuration. In time, the standard tank configuration adopted in the design of fighting vehicles consisted of the driver at the front, the turret mounted in the middle and the engine installed at the rear. This vehicle fitted a 3-man turret and comprised a crew consisting of a commander, gunner and loader. In this section, we will look at the key fighting vehicles used during World War II. As you may know, tanks and fighting vehicles played a pivotal role during many battles of World War II. But surprisingly, it wasn't until towards the end of military operations in 1945 that the Allied armies finally came to accept that the tanks were best utilized as a mobile protected gun platform. By this time, Western armies also had come to realize that tanks were most effective when operating as armored formations rather than as support to infantry. Some of the key technology developments affecting fighting vehicle design during World War II included the broad use of independently sprung road wheels to greatly improve vehicle mobility, and the introduction of guns that could use varying natures of ammunition. These different types of ammunition included high explosive and armor-piercing rounds. The clear pattern that emerged during World War II was the cycle of increasing firepower through the fitting of larger caliber weapons, leading to the need for higher levels of vehicle armor protection. This cycle then repeated itself through the fitting of higher caliber weapons. It's amazing to think that this design cycle was repeating itself almost every 6 to 9 months during World War II. One of the most effective battle tanks of World War II was the Soviet T-34. The T-34 tank was based on the earlier BT-7 tank. It provided superior mobility, firepower, and protection compared to its Allied counterparts. The vehicle's high mobility came from the fitting of the American-design Christie suspension. You'd be interested to learn that the Americans shunned the highly innovative Christie suspension. It was adopted to great advantage by the Russians. As you can see, the vehicle was built in great numbers, with more than 55,500 being produced during the period of World War II. It used 45mm thick armor and mounted an 85mm tank gun. The T-34 tank is known for its simplicity of design and high reliability. Another very highly regarded tank design of World War II was the German-designed Panther medium tank. It was first built in 1943 with a maximum combat weight of 43 tons. This vehicle introduced a 75mm, 70 caliber high-velocity gun, which was highly effective against Allied tanks and fighting vehicles of that period. Like most of the German vehicles designed for operation during World War II, it used a mechanically advanced design, with a compact engine installed at the rear. It also used a novel dual torsion bar suspension design with interleaved road wheels. Whilst the interleaved road wheels provided very high levels of mobility, this design led to high levels of track separation due to dirt and ice build-up between the road wheels. It also required higher levels of maintenance to service the road wheels located on the inner side of the track. It's interesting to note that interleaved road wheel designs have not been used since World War II. This tank is considered the best medium tank of World War II, and well ahead of its peer tanks designed and manufactured in the US and UK. For those of you interested in the largest tank ever designed, you need to look at the German Rata. This tank was designed by Krupp in 1942. It weighed a massive 1,000 tons and housed a crew of 20. It was fitted with two 280mm naval guns, and 8 20mm anti-aircraft guns. If this vehicle was ever built, it would truly have been massive. To power the vehicle, it used 4 large MAN engines, with an installed horsepower of 17,000. At an all-up weight of 1,000 tons, you wonder what roads or bridges it would ever have been able to travel. Certainly, a creative design but totally impractical for modern warfare. Another interesting tank from the World War II era is the Australian-designed Sentinel tank. This tank weighed 28 tons and had a crew of 5. The crew consisted of a commander, gunner, driver, loader, and radio operator. This crew arrangement was common for fighting vehicle designs of World War II. The novel design aspect of this vehicle related to the fact that it was made from a single cast hull, rather than welded steel plates. This is the only tank of its type to ever have used this unique manufacturing process. Unfortunately, the project was cancelled in 1943 due to pressure by the American government. At the time, the Americans considered that the production of the Sentinel tank was diverting important technical and other resources away from other essential World War II production activities. We now come to modern-era fighting vehicles, many of which are still in active service today. Following World War II, there was a burst of technological development that greatly enhanced the combat effectiveness of military fighting vehicles. Many of these technological developments were spurred by the Cold War and competition between the US, its allies, and the Soviet Union. The key design and technological developments over the past 50 years included the development of the T-72 tank, which led to the fitting of the first automatic ammunition loaders into tanks. This had the considerable operational benefit of reducing the standard crew size from 4 to 3. There were dramatic improvements in armor protection through the development of chobham armor by the United Kingdom. Chobham armor is widely used in Western heavy tank designs of today. During the 1950s, we saw the design, experimentation and development of various gas turbines for land vehicle applications. Most of these developments were unsuccessful, but the USA persevered and successfully developed the Lycoming AGT 1500 gas turbine for use in the M1 tank. At the time, the US considered this to be a superior engine technology compared to diesel engines due to the gas turbine's highly desirable torque characteristics, quietness of operation, and its ability to be a truly multi-fuel engine. However, it has a considerable range of disadvantages, which we will learn about later in the course. We also saw the development of hydropneumatic suspensions. The development of this new type of suspension, although more complex and expensive, provided for much higher levels of mobility. And finally, we saw the fitting of large high-velocity guns, with calibers of 120 and 125 mm. The 120 mm tank guns are fitted on Western tanks, and the 125 mm guns are fitted on Russian tanks. We also saw the introduction of automatic tank fire control systems, laser rangefinders, and ballistic computers. These greatly enhanced the first hit probability of tank gun systems. And finally, there was the design, development and introduction of long rod penetrators, which proved to be very effective in killing tanks and other fighting vehicles with high levels of armor protection. These long rod penetrators used a nature of ammunition known as APFSDS, which stands for armor piercing, fin stabilized, discarding SABO. During the period from the 1950s through to the 1980s, there was a broad range of fighting vehicle developments that occurred across the world. Some of the developments in the West were undertaken as collaborative projects. The interesting feature of these projects is that most of them failed. This was due to the inability of the collaborating nations to agree on key operational and technical design requirements. Over the next few slides, we will look at some of the more important fighting vehicle developments of the modern period. These include the Soviet T-72, the British Challenger 1 tank, the US, German MBT-70 collaborative tank and the Swedish S-tank. All of these tank designs have their own innovative and unique features. The T-72 first came into production in 1970, and over the last 50 years about 20,000 tanks have been manufactured. This tank is the first to use a horizontal ammunition autoloader, which is installed in the base of the turret. This design feature allowed the Russians to reduce the crew of the T-72 from 4 to 3. This main battle tank is also light, weighing in at 41 tons, and has a low silhouette compared to its peers in the West. The low silhouette and resulting low tank height means that the crew all need to be quite short in height. The maximum height of a T-72 tank crew member is 5 feet 1 inch, or 1.57 meters. The tank has a respectable power-to-weight ratio of 19, and uses a high-powered 125mm smoothbore tank gun. Over the years it has been exported to many countries under the designation of T-72M. Another notable tank of the modern era is the British Challenger tank. It first entered service in 1983 as the Challenger 1, and in more recent times has been upgraded to the Challenger 2 configuration. It uses the standard conventional tank design and carries a crew of 4, being a commander, gunner, ammunition loader, and driver. The key technological advances associated with the Challenger tank include the introduction of the highly effective Chobham armor system and a hydro-pneumatic suspension. Note here the all-up combat weight of the Challenger when compared to the T-72 tank. It is some 20 tons heavier. The MBT-70 tank represents one of the more interesting designs developed as a collaborative project between the US and Germany in the 1960s. The MBT-70 project was finally cancelled in 1971 due to massive financial overruns. However, the project is notable because it led to the development of the German Leopard 2 tank and the US M1 Abrams tank. Like the T-72 Russian tank, the MBT-70 used an ammunition autoloader, which resulted in a crew reduction to 3 and minimized the overall vehicle weight to 50 tons. The novel design incorporated into the MBT-70 tank included a counter-rotating capsule, located in the turret, which housed the driver. This meant that when the turret was turning in one direction, the driver rotated counterclockwise in the other. Locating the driver within the turret was found to be problematic, as drivers reported feeling quite disoriented during driving operations. The vehicle initially fitted a high-powered gas turbine engine, but this was swapped for a conventional 1500 HP diesel engine. This engine arrangement provided a very respectable power-to-weight ratio of 30 horsepower per ton. The vehicle also installed the XM150 gun launcher system, but this new weapon system was found to have serious technical problems associated with the use of caseless ammunition technology. The final vehicle we will look at is the Swedish S-tank. You can see that this tank uses an unconventional turretless design, which means that the gun was fixed to the chassis. So how do you fire this tank? To do this, the tank used a highly sophisticated and complex suspension that allowed it to dip so that the gun could be aimed in elevation. To aim the gun in azimuth required the gunner to pivot the tracks. So, while the vehicle eliminated the need for a conventional turret, thus obtaining a very low silhouette, it required a very complicated suspension and integrated steering and weapon aiming system. Of particular note is the fact that the vehicle cannot fire on the move. Such a design appears quite strange, but this design actually supported the Swedish defensive military strategy at the time. The other novel aspect of the S-tank design is that it used a hybrid diesel gas turbine engine. This particular engine arrangement provided for very high mobility as the gas turbine, which has very desirable torque characteristics, can be used at low vehicle speed in difficult going to provide excellent mobility. But when the vehicle is stationary, or the engine was operating at part load, the diesel engine kicked into operation to provide high fuel efficiency. The S-tank is a very nice but complicated design. I trust that you have enjoyed the historical overview, covering the key technological developments of military fighting vehicles over the last 100 years. Before you move on to the next section of the course, please ensure that you have completed all the readings, videos and short quiz.
The Romans built a siege engine called the gallery. It provided protection for the soldiers within as it approached a castle wall. Even Da Vinci made conceptual drawings of an armored vehicle. With the Industrial Revolution, armored vehicles were being realistically conceptualized around the turn of the century. There were prototypes of various machines put to paper, and some even made it off the drawing board. In 1896, an American, E.J. Pennington, suggested an armored car with 2 machine guns and surrounded with plate steel. A Motor Scout, a 4-wheeled bicycle carrying a Maxim gun with a bulletproof shield to protect the gunner, was suggested by British engineer F.R. Sims in 1899. In 1902, Mr. Sims went on to design a war car with a new Daimler internal combustion engine, 2 Maxim machine guns, and a 1-pounder naval gun. It was manufactured by Vickers and had a top speed of 9 miles per hour. H.G. Wells, in a 1903 article in the Strand newspaper, wrote about the land ironclad. It stirred people into considering land cruisers and battleships. The various technologies were available, however, just not combined in the right or practical mix. In 1906, the Holt Company of the USA fitted a steam tractor with a tracked suspension. A year later, British company Hornsby built a petrol-driven tracked vehicle in response to a request from the War Office. The following year, a Major Donahue took the Hornsby proposal and suggested adding armour and producing a gun carrier. Discouraged by bureaucratic stalling, Hornsby sold their patent to Holt. 1912 saw Australian engineer de Mol present a set of drawings to the War Department of a fully armoured tracked vehicle, as too did an Austrian, Burstein, who produced drawings of a lozenge-shaped fighting vehicle. In 1914, 3 armoured vehicles were built, based on a Rolls-Royce chassis with a Maxim machine gun mounted on a turret with 360 degrees of traverse. But an established military machine, with its corps of infantry, cavalry and artillery, could see little use in these armoured vehicles. A few far-sighted people, however, did see a practical use for such a mobile force. One man, an ex-soldier who had fought the Boers in South Africa and later turned to politics and eventually become the First Lord of the Admiralty, conceived of some daring uses for an armed vehicle. He was a young Winston Churchill. Churchill wrote several proposals for the defence of the nation, which included the use of vehicles carrying Maxim guns or cannon, able to manoeuvre on the battlefield and defend British air bases in Europe. With the commencement of World War I, it quickly became apparent that military doctrine and battlefield tactics based on the past had no hope of being effective against the new weapons of war, namely machine gun, massed artillery fire, and aircraft. The swift movement of the armies of old ground to a halt, literally, and descended into the hell of trench warfare. For some commanders, it was a matter of relying on the old ways. For others, they were hoping for new battlefield initiatives. Perhaps technology would change the balance. Lieutenant Colonel Ernest Swinton of the British Royal Engineers was sent to the battlefields of France to see for himself the situation and perhaps suggest a method of breaking the trench stalemate. Swinton had suggested back then that a method of breaching the trenches needed to be found, perhaps with an armoured caterpillar with a Holt track mechanism. A member of the Defence Committee, Lieutenant Colonel Maurice Hankey, ran this idea against overall rebukes from the committee, but undeterred took a refined version to Cabinet. This proposal included bulletproof rollers for the tracks. Churchill was impressed and encouraged this development. One Naval Captain T. Tulloch advanced the suggestion of land cruisers and land destroyers. Even a land battleship carried on massive 40-foot wheels. Churchill could see merit and advanced £70,000 of Admiralty money towards a pilot model. Little Willie was conceived and built with Maxim machine guns and a 57mm naval cannon, and a suspension track system developed by Wilson. The device was coming to fruition and was classified top secret. A new name was to replace Landship, and it was dubbed the Tank. Churchill continued to develop his thoughts on the tactical methodology of this new weapon. Soon Big Willie, or Tank Mark I, was completed. It weighed in at 30 tons, with a 105 horsepower engine. The male version carried 2 cannons, the female 2 Maxim machine guns. 100 were immediately ordered. Swinton began to develop the how-to manual for the troops who were about to become tank men. General Haig needed all the help he could get on the Somme offensive and eagerly accepted 50 tanks with only partially trained crews. Something was better than nothing. However, the doctrine in use of these vehicles was confused and ill-defined. Few, if any, tanks had radio. Most would rely on visual signals for communications. The day of battle, the 15th August. Of the 49 tanks available, only 36 reached the start line. A single tank, numbered D1, moved off and assaulted the German lines with machine guns blazing, and was unceremoniously hit and instantly put out of action. But it was the first tank attack in history. A second front of tanks moved ahead with greater success. Tank number D16 moved into the small town of Fleur, followed by infantry. 3 battalions of Germans fell. Another tank, D5, late into the action due to mechanical trouble, punched straight through the lines and on to the enemy artillery placements. A duel ensued, tank versus artillery. The tank did well until it had to withdraw when it was hit and set alight. Individual tanks did achieve a lot, but their unreliability and eventual vulnerabilities seemed to tarnish them. However, some believed if they were to be used together in a larger formation, more could be achieved. Besides, the infantry who had ventured forth with the tanks knew immediately they would rather be with them than without, particularly when crossing no man's land. The British combined 400 tanks in one push along a 7-mile front, their first attempt to manage such a large tank assault. Unfortunately, the infantry failed to follow up on their advance and secure their successes. Even by 1918, towards the end of the war, tanks had been used haphazardly and not used in any defensive role. No one understood this capability. March 21st. A German push encountered British tanks in isolation and quickly overpowered them. It was then towards the town of Vauvaucourt that a group of 30 British tanks were able to slow the German advance. But German forces had made a breakthrough. With no infantry immediately available, 12 newly arrived Whippet tanks were raced to the scene. They attacked headlong, halting the German advance until infantry could secure the battlefield. 5 a.m. on the 11th of April. 3 mail tanks await with infantry outside the town of Monchy-le-Preux. The promised artillery barrage has not materialized. The crouching infantry sensibly refuse to move forward into the German machine guns. The 3 tanks cannot retreat from their redoubt as they would be picked off in the daylight by artillery. There is only one way to go, forward, and assault the 200 entrenched Germans on their own. They advanced. The terrified Germans ran and the town fell without a fight. The tanks rolled through the village and out the other side. The Germans regained their composure, realized there was no infantry following the tanks and moved back into the town. The 3 tanks turned and had to attack all over again. This time they are hit with everything the Germans have, including armor-piercing rounds. Soon one tank is afire, a second is hit, but the crew keep firing until they are destroyed. The 3rd tank was gaining the upper hand when the delinquent artillery barrage finally arrived, destroying the town, the Germans, and the last surviving tank. This was the first time tanks had assaulted alone, and with great success.
Tanks, There is perhaps no symbol greater of modern warfare than the tank, and in this video we're going to take a look at some of the most ridiculously oversized tanks that have ever been designed. To begin with something a little familiar, we're going to start with the American-made M1 Abrams main battle tank, which is still currently used in service. The vehicle weighs a mighty 62 metric tons, equal to the weight of about 49 2016 Toyota Corollas. It possesses a main gun of 105mm, meaning the shell that it fires from the turret is 105mm in diameter. There are 3 secondary machine guns located around the tank as well, and the vehicle is crewed by a 4-man team. Individually, each M1 Abrams tank costs $8.92 million to produce, but this is just scratching the surface of monstrously huge tanks in history. Arguably, the largest tank in terms of physical dimensions ever built was way back in the First World War and was made by the French. It was named the Char 2C and features a prominent role in the latest Battlefield 1 expansion pack. It was designed in 1917 when the First World War was still raging, but the first unit wasn't actually built until 1921, 3 years after the war had ended. The tank weighed 69 metric tons, a little heavier than the modern Abrams M1, and featured a 75mm main cannon along with 4 secondary machine guns placed in the front, the sides, and the rear of the vehicle. This monster tank was 10.27 meters long and 3 meters wide. It took a crew of 12 men to fully operate the machine, but France only ever built 10 of them, which wasn't enough to turn the tide of World War II when the Germans attacked again. However, an even more absurd tank from the First World War was the German-designed K-Wagen. This beast was so large that it was impossible to transport it in its fully built form, so the Germans had to disassemble it into 6 separate pieces, transport it by rail, and reassemble it just behind the front lines. One such tank actually was finished just before the war ended, but never actually saw service because Germany surrendered before it could be used. If it had been utilized, however, the Western Front would have witnessed a 120 metric ton monster, nearly twice the weight of a modern M1 Abrams tank. It was 13 meters long, just 2 meters shorter than the width of an NBA basketball court. It came equipped with not 1, but 4 different 77mm Fortress guns and 7 MG08 machine guns. It was intended to have a crew of 27 men, 1 commander, 2 drivers, 1 signaler, 1 artillery officer, 12 artillery men, 8 machine gunners, and 2 mechanics. The addition of flamethrowers to the tank's already fearsome arsenal was also considered to be added, but was never realized. Eventually, when the Second World War rolled around, the design of truly ludicrous tanks would begin. The Nazis would design possibly the most absurd of all of these tanks, however, the first being the massive Panzer VIII Maus. This is the heaviest tank still to this day that has ever actually been built, and weighed an enormous 188 metric tons, nearly 3.5 times the weight of a modern M1 Abrams tank. This behemoth featured a 128mm main gun capable of destroying any Allied tank in the war from a distance of 3.5 kilometers. It also had a secondary 75mm cannon as well as 1 machine gun. It possessed 220mm of steel armor plating on the front and was intended to be operated by a crew of 6 men. Because of its sheer size, however, it faced numerous problems. Firstly, it was so heavy that it couldn't drive over any bridges without collapsing them beneath its own weight. So if it needed to cross a river, then it had to go underneath it, and the crew would use a snorkel to pump air into the main cabin, which is just ridiculous. Finally, if there ever was a real-life boss battle against an evil enemy worthy of a video game, it would have been against the German-designed Landkreise P-1000 Ratte. Personally approved by Adolf Hitler himself, the finished tank was intended to weigh 1,000 metric tons, which is over 5 times heavier than even the Panzer VIII Maus, and over 16 times heavier than a modern M1 Abrams tank. 300 tons of the total weight would have been devoted entirely to munitions like shells for the cannons and bullets for the machine guns. It was planned to be 39 meters long, longer than the length of an NBA basketball court, as well as 14 meters wide, which is roughly the same width of a basketball court. The monster tank would have been powered by 2 24-cylinder marine diesel engines, the same engines that were used to power U-boat submarines. This would have given the tank an unbelievable 16,000 horsepower that could have propelled it up to speeds of 40 kilometers per hour. The Landkreuzer's primary weapon would have been a dual 280mm SK C/28 turret. This was the same turret that was used on Germany's main battleships. And to put that into perspective, the barrel of the Landkreuzer cannon would have been almost 4 times wider than the barrel of the modern Abrams battle tank. In addition to this terrifying main cannon, the Landkreuzer was also armed with a 128mm anti-tank gun, which means that its secondary cannon was the same size of the main cannon on the Panzer VIII Maus. It also would be equipped with 2 15mm Mauser autocannons capable of shredding smaller vehicles to pieces, and a total of 8 28mm Flak 38 anti-air guns to defend the behemoth against air attacks. The tank also would have come equipped with a vehicle bay that could hold 2 motorcycles for scouting operations. It had its own medical room and even had its own bathroom. It was intended to be operated by a crew of 41 men, but a tank of this size was doomed for failure from the start. It was never built because it was determined that despite being armed with 8 anti-aircraft guns, the tank would still be too large of a target for enemy planes to attack.
This wild experimentation of tank design could well have cost Germany the war. Germany gained the majority of their territory in the first year of World War II, when their tanks were inferior to the Allies. Their success was largely a result of their overwhelming numbers and speed when attacking, not having the best tank. By the time the invasion of Russia began, Germany had the most advanced tanks, but they were met with what seemed to be a never-ending army of T-34 tanks. A fantastic yet crudely constructed tank. It was designed with high speed and low cost of manufacturing in mind. The Blitzkrieg was finally halted at the Battle of Kursk, the largest tank battle in the history of humankind. This battle depleted the German war effort like no other, and the Germans would struggle to take a step forward again.
Please make sure to go watch Real Engineering's video next for more fascinating tank information. If you enjoyed what you just watched, then I hope that you'll subscribe to my channel by clicking here. You can visit my Patreon if you'd like to support the channel by clicking here, and I hope to see you again for another new video in 2 weeks on Friday.